Alright, so this is going to be the proof of the sum identity of cosine. So we already proved the difference identity of cosine, right? That's cosine of theta minus beta equals cosine of theta cosine of beta plus sine of theta sine of beta. Now, what are we looking for? We're looking for the sum identity. So we know it's going to look like this. Theta plus beta. But how can we rewrite the plus using something that we already know? How can we rewrite it as a minus? What we can do is we can say cosine of theta minus negative beta, right? Because a negative and a negative is a positive. So then from there we can use our formula here, right? So we say equals cosine of theta, because the theta is still the same, then cosine of negative beta plus sine of theta, then sine of negative beta. So from here, what does this equal? In order to figure that out, we have to know our even and odd identities. So cosine, because let's do a recap of the even and odd identities here, but this is a circle. It's our unit circle. So if we go, we know that we can call a point with its trig identity. So this would be cosine of beta with sine of beta, because this angle here is beta, right? And then we're going to say this is cosine of negative beta sine of negative beta, because it's the same angle just going in the opposite direction, right? So that's what this is, negative beta. So I'm just going to draw a line to make it show that this is the angle. So what do these have in common? Well, they're both, in order to get there, you go this way and this way and this way and this way. So to get here, they're going the same x value. So whether beta is positive or negative, the x is going to be the same. So for cosine, so we know that the output of this is going to be cosine of theta cosine of beta, right? But here we notice that sine isn't the same as the sine. The direction you go for sine of beta isn't the same as the direction you go for negative sine of beta. While it might be the same distance from this axis here, it's not exactly the same, because obviously they're going two different directions. So this distance here is the same as this, just the opposite. So we can write that as negative sine of beta. So then we'll say plus sine of theta, then negative sine of beta, right? And then that can simplify to be cosine of theta cosine of beta minus sine of theta sine of beta, right? Because this is multiplied, so these two would be negative. And then that equals cosine of theta plus beta. There we go. And that's the proof of the sum identity of cosine.